Hey guys, welcome back to my channel Success Engineering Official. So, our next step is step number 4. We have did this first part, that is fresh air calculation. Now we are doing the design of FAHU, the fresh air handling unit, manually. So you can see this is one of Excel sheet. Okay, so in this Excel sheet we have to just put the value and we will get the answer. This is the Excel sheet for design of fresh air handling unit, and this is for the Hyderabad. So we will see for this Saudi, or we can see for the UAE weather. So I will just show you how to use this Excel sheet for this our project. So you can change here the location. So before I start this video, I would like to request you guys, please, if you are still not subscribed my channel, please do subscribing and hit the bell icon as well, so that you can get the notification of my upcoming videos. So let us start now. So you can see this is the location. You have to change the location here, make it UAE. We'll do the calculation for UAE. Okay, and this is the outside dry bulb temperature and outside wet bulb temperature. So how to get this value? Let us open this app software. Okay, and cancel this. Cancel. So go to this weather properties and double click this weather, and you can select here the region Asia Pacific or Middle East. Okay, and in the Middle East you will find here UAE, and I am going to calculate for Dubai. So for Dubai you can see here, you can find this summer design dry bulb is 107 and wet bulb is 75. So simply change this one, 107 and wet bulb is 75. Okay, so simply remove this. Okay, I did this for the our other project. Okay, so here is the CFM. So our let us open this our Excel sheet which we did it load calculation. So in our Excel sheet we got here 400 sorry 4 ton. So how much is the CFM? So 1 ton is equal to, here as per thumb rule, 1 ton is equal to 400 CFM. Okay, so in our case our tonnage is 4. So 4 into 400, we are getting 1600 CFM. Okay. 4 into 400, we are getting 1600. Okay, 4 into 400 is equal to 1600. Okay, so this is our CFM for our project. So what you will do, you have to simply enter here 1600 CFM. Okay, and the dry bulb temperature is nothing but, here is on coil and off coil. On coil in the is nothing but, this is the ambient temperature and this is the indoor temperature, human comfort temperature. Okay, so here is the fresh air. So here is the FAHU, simply rename this, and getting 1600 CFM, and dry bulb temperature is 107 degree Fahrenheit. Okay, and wet bulb temperature is 75 degree, and these two value we can found from the psychometric chart. So if you know these two value, you can found this another two value. So let us open this psychometric chart. Okay, There is this is software for psychometric software. So there is chart as well, so you can use that chart also. Okay, so what you will do, how to use this psychometric software, simply click here new. Okay, and you can see here this is a set point. Okay, simply click here and add, just add the point. So we know the two values, so our values is, we know the dry bulb and wet bulb temperature. So what we will do here, simply select enter here dry bulb temperature. So dry bulb temperature is 107 degree Fahrenheit, and you can select here whatever value you knows here. So we knows wet bulb temperature, so our wet bulb temperature is 75 degree. So simply enter here 75 degree Fahrenheit. Once you enter this, let me zoom this one. Let me try to zoom this so you will get it clearly. Okay, so you can see here, once I enter the weight valve value 75 degree, so it's zoom now. uh, okay, so let me show you. Okay, so you can see here, once I enter the weight valve value here, I am getting here different so many parameters. So in this I can found here RH. RH is nothing but the relative humidity. So RH is 22.4. So simply enter this here, relative humidity. So relative humidity is 22.4, and this is from the psychometric chart as well, this W. So W is here, you can found here this psychometric chart as well. So let me zoom for you, and this is the humidity ratio, we can say grain per pounds. The unit is grain per pounds and is called humidity ratio. So humidity ratio in our case is 79.5. So let us enter this value here, 79.5. So this is these two are user input, and this value, let me change this, no fill, and let us match this. So these two are user input, and this is we have to pound. Okay, so this is over, and in the second this is the off coil temperature. So off coil temperature is here 72 degrees for human comfort temperature, and 50 degree is the relative humidity for human comfort temperature. Okay, so 24 and 50%, this is 24 degree, and this 72 degree Fahrenheit is, if you convert this you will find 24 degree. So in this case, human comfort temperature, we knows. So two value we knows. So if we enter this two value, we will get this another two value. So again, you have to use a psychometric chart. You can save this point, or so we have applied, and you can add another point. So point number two is you can rename here off coil, off coil, and this is okay. Okay. So here off coil temperature is 72 degree, and you can select here relative humidity. So relative humidity is 50%. So we can get it here, the wet bulb temperature here. Wet bulb temperature is 60 degree, and humidity ratio is 58.6. So let us enter here. Wet bulb temperature is 60 and humidity ratio is 58 point. 6. Okay, so this is same. Okay, so this value is okay. Now is the SH is nothing but the sensible heat and latent heat. So sensible heat, the formula is you can see here, the 1.08 into CFM into delta T, and latent heat is 0.68 into CFM into delta T. So let us found this total tonnage. Let us found here sensible heat. So our formula for sensible heat is here. Here 1.08 CFM into delta T. So simply enter here. Our CFM is 1600 into delta T is nothing but the temperature outside minus inside. So outside is 107, inside is 72. So let us calculate this, how much we are getting. 1.08 into CFM 1600 into 1728, and delta T is 107 minus 72, 35. Okay, 1.08 into 1600 into 35, so 60480 BTU per hour. Here sensible heat is 60480, 60480 BTU per hour. Okay, so convert into tonnage divided by 12,000. We are getting 5 ton. Okay, so here is your 5 ton FAHU is required, 5 tier. Similarly, we can calculate the latent heat. So you can enter here 60480, 60480. So I am getting here the tonnage for sensible heat, and latent heat 35668. So also calculate the latent heat. Okay, so latent heat is here 0.68 into CFM into delta T. So simply enter here CFM 100 1600, and delta W. This is the delta W is nothing but 79.5 minus 58.5, 58. Okay, so 79 minus 58. Okay, 79.5 by 68.6. Just calculate it. 0.68 into, simply first subtract this one, 79.5 minus 58.6 into 1600 into 0.68. So we are getting 22,739 here. 22,739 BTU per hour. 22,739. 22,739 BTU per hour is the latent heat. Okay, so total heat is nothing but the sensible heat plus latent heat we added here. I added here both of these. Okay, so total tonnage is 6.9 ton FAHU is required. So I think you guys learn how to calculate, how to design the fish air handling unit manually. So thank you for watching my video. So if you are still not subscribed my channel, please do subscribing and hit the bell icon as well, so that you will get the notification of my upcoming videos. Whenever I upload the video, you will get the notification for that video. So thank you for watching my video. Thank you. Bye bye.